So hello friends, now I am going to discuss another concept in modeling and simulation, that is random variate generation. So for random variate generation we have the technique inverse transformation technique. So inverse transformation technique is in two forms, uniform distribution and other one is in exponential distribution. So first I am going to discuss how to generate random variate using our uniform distribution. So here I have taken one simple derivation for our uniform distribution in inverse transformation technique. So if a random variable x having uniform distribution in the interval a to the b has the following probability distribution function, which I can write as fx when x lies into the range a to b is 1 upon b minus a and 0 if otherwise. And respective cumulative distribution function we can write as, so 0 if x is less than a, and if x is lies between a to b it will be x minus a divided by b minus a, and 1 if x is greater than or equal to b. So for generating a formula for uniform distribution in inverse transformation technique, I am going to discuss in step by step form. So for step 1, if the cumulative distribution function fx is given as x minus a divided by b minus a, so respective if we take set fx equal to r, so this value will simply is equal to r. And now if we just simply solve it, so it will be equal to x minus a will be equal to b minus a into r. By multiplying by solving these values, we can get here x is equal to a plus b minus a into r. And now in step 4, if given a set of random numbers ri, so r is here represent number of random numbers, and we have to compute xi. Xi is what? Random variate, using the above formula, this one. So simply we can, in general terms, we can write this formula as xi is equal to a plus b minus a into ri, where ri is a respective random number and a and b are the intervals where we have to calculate in random variate. So now using one formula I am going to discuss how we can do these things by using a formula. So for that I have just taken a simple example. So here interval I have defined as 3 to the 4, where a value is 3 and b value is 5, and respective random number I have taken r1, r2, r3, r4 and r5 as 0.7, 0.779 and 0.921 and 0.186 and so on. So now we have to use our formula xi is equal to a plus b minus a multiplication with ri. Ri is nothing but respective random number. So for each random number we will get respective our random variate. So for that I have just summarized this in the form of table, as it will be a long calculation if I go for each step. So for here I have taken ri, that is respective random number and respective random variate. So for ri, so for 0.779, if we take here and put the value of a is 3 and b is 5 and multiplied with respect to this one, so we will left with 4.558. and same we will do if for 0.921 random number, this one, and if we use put the values in respective random variate formula, we will get the value 4.842. and for third one also, if we take the random number 0.186 and we use our standard formula for uniform distribution, so we will get the value 3.372. and for r4 and r5 we calculate accordingly. So this is the simple process. Here I have discussed what is the inverse transformation technique in uniform distribution. So here we have to just remember this formula. This is one formula xi is equal to a plus b minus a multiplication with ri, and the random number we can generate, or it will be given in the question, and a and b will be the range of the interval where we have to generate random variate. So this technique is used in uniform distribution for random variate generation. So thank you all. Thank you for watching this video.